So how long will it take this time for this pattern? How long will it take until everyone is a zombie or a walker? 5 weeks. Yep. So somewhere between 5 and 6 weeks. Because if I do 96 times 2, I get 192, and then no more people are left. Okay? And what's the pattern again? How do I get from one number to the next? Geometric. It's a geometric sequence. What are we doing to that geometric sequence? Doubling. We are doubling again, and we are going to list the sequence. That's what part B says. List the sequence. So it went 3, 6, 12, 24, 48, 96, and you're right. It's another geometric sequence, like the one we did on the first page. We are going to write a recursive formula. So what was the first term? How many zombies did we start with? 3. And then to get the next term, we did the previous term and did what to it? Times it by 2. Fantastic. If instead there were an infinite number of humans in the town, how many walkers or zombies would there be in week 8? Well, week 5 is 96. If I times that by 2. So week 7 would be 192. How would I figure out week 8? Times that by 2, we get 384. Let's see if you can find week 13, week 24. The numbers are going to get large. It's a lot of multiplying, so if you can't get to week 24, that's okay. But essentially, we're just taking the previous number and timesing by 2. It would be nice if we had a formula. How could we figure out how many total walkers there are for any week? What we're going to do is we're going to write an exponential function. Will you make a little side note here? We're going to write an exponential function. Okay? So the number of walkers, or zombies, is going to equal 3 times 2. And we're going to use x. X is going to be number of weeks. Notice how x is in the exponent. It's in the power. We're ready. Okay. Number 3 says, for a certain area, the equation is y equals 6 times 3 to the power of x, where y is the number of walkers and x is weeks. Explain what the 6 and the 3 tell us about the walker population in this area. Turn and talk with your group. What does the 6 and 3 mean in terms of the walker population in this? Start with 6. And then the pattern is times by 3, or you could say triples. Flip to the next page, please. Next page. Exponential functions. Writing the function. Writing the equation or the function. It's going to be y equals a times b to the power of x, where a is your starting value and b is your growth rate. Or I'm just going to write our multiplier. It's our multiplier, okay? That's how we write an equation. we are going to compare exponential versus linear. So in the graph that we made for the first zombie or walker situation, we notice it was a curve. A curve is going to be exponential. A straight line is going to be linear. So when we're comparing these things, linear versus an exponential pattern, linear adds or subtracts. What does exponential do? What does an exponential function do? Yeah, multiplies or divides. So if I look at a graph, linear is going to be a straight line. Exponential is going to be a curve. It could be going up. It could also be going down. In this lesson, we also reviewed sequences, which was good review from Unit 1 because your final exam is coming up. Table is an exponential function. We are missing the values j and k. So let's talk about how do we figure out j and k. The first thing we're going to do, for finding the multiplier, I'm going to look at these 2 points, 1 and 2. They are in a row, point 1, point 2. And what I'm going to do is I'm going to divide the second y value by the first y value. Can you do this with me? Because some of you are going to get to the homework and you're not going to be sure how to find a multiplier from a table. To find a multiplier from a table, you take 2 points in a row and divide the y values. Can someone do that on their calculator for us? 5. It's 5, so the multiplier is 5. So make a note. This is how we find the multiplier. This is the b value in y equals a times b to the x. Now, to go backwards, going forwards, we're timesing by 5. But to go backwards, what should I do to undo the multiplication? Divide. I'm going to do 15 divided by 5. And what must the j value be? 3. So j is 3. How are we going to find k? We're just going to times it. Good. We're going to do 375 times 5. What do we get? 1,820. Great. That's k. We're going to use this now to put the equation together. And we're going to use f of x. Now, just like an linear equation, this 0j value, which we found was 3, that's my a value. That's my starting term. Okay, so 0, 3, that's your a value, and y equals a times b to the x. So I'm going to start with 3 times, what's my multiplier? 5 to the power of x. How do we feel about that? Yes, no, how do we feel about that? What do you think for A? We got University of Michigan football tickets. Each price is expected to increase by 5%. Exponential, yeah. This is going to be an exponential relationship. How about the equation in part B? Is that exponential, linear, neither? Anyone know from my parent graphs over here what it is? What? Quadratic. Yeah, it's actually quadratic. How about in part C? We got a table. Linear? We said exponential. It's adding 1.5 each time. Did you see that? Adding 1.5 consistently. So this would be linear. We're adding 1.5 each time. What about D? What do you think for table D? You said what? Exponential. Why?
Because it's dividing by 2 each.
It's dividing by 2? or we could say being times by 1/2, it's going to be exponential. What questions do we have?